Hello, good morning everyone. I'm Tanzila Binti Alom and my partner is Shams Nafisa Ali. Today we will be presenting on an integrated mHealth solution for detection of neonatal encephalopathy. Neonatal encephalopathy is defined as abnormal neurological symptoms that appear in a newborn baby during the first of life. If infants are deprived of oxygen for an extended period of time during birth, its brain tissue is damaged and leads to brain injury. It affects 2 to 9 out of every 1,000 births worldwide, and the majority of victims die before reaching the age of 2 or have severe permanent disabilities. In Bangladesh, neonatal death rate by birth asphyxia is severe, and the rate was 43% in 2019. For treatment, hypothermic therapy must be initiated within 3 days after birth. This is the reason why early and accurate detection of encephalopathy is vital. In Bangladesh, the clinically established methods for detecting neonatal encephalopathy are MRI, EEG, and the Cerner scoring tool. They are either time-consuming or require manual handling and are inaccessible to the majority of the population. Other issues that can be mentioned include very high diagnosis cost of MRI, lack of access of these systems, as well as shortage of NICUs and medical specialists, diagnosis delay for manual handling procedure, and shortage of services, manual detection by radiologists and specialists, and also MRI posing potential health risks to infants. We need to understand relevant physiological parameters for automatic encephalopathy detection. EEG, heart rate variability, and peripheral oxygen saturation reveal significant information for accurate and safe diagnosis. So, to detect encephalopathy safely and accurately via mHealth system, we are looking for baby's EEG pattern, PPG. From PPG, it is possible to measure heart rate variability and pulse oximetry. Relevant maternal cytos can also be collected via smartphone app easily. So, our proposal is to develop an integrated mHealth solution for detection of neonatal encephalopathy using amplitude, EEG, and PPG. Our project objective will be integrating numerous cutting-edge technologies into a single smart mHealth tool for reliably predicting encephalopathy while lowering costs. Using app-based telemedicine technology, remote test-equipped healthcare practitioners without a specialty in pediatrics can rapidly intervene with expert assistance. We are providing the severity grading of encephalopathy stages, which is critical for timely intervention and management of many patients at a time. By identifying encephalopathy using numerous diagnosis devices, we are removing loads from overburdened health complexes and clinicians. And by utilizing the collected data, we can facilitate clinical investigations and create a validated community-based framework to operate with greater conviction. Our target beneficiaries are urban residents primarily and remote residents of underserved rural areas, suburbs, hill tracts, and other remote areas. And to serve beneficiaries, our potential purchasers will be government, primarily for Upazila health complexes, local community clinics, private agencies, military-owned healthcare centers, and non-profit primary and secondary level healthcare organizations. To target an extended group of potential purchasers, customer demographics, operating characteristics, customer purpose, purchasing policies, technological adaptation must be uplifted along with technological advancement. Now, let's have a look at our proposed service flow diagram. Mother metadata, EEG, and PPG will be recorded by smartphone with the help of the mHealth device. Then the data will be sent to a cloud server where necessary and data processing and automatic detection of encephalopathy will happen with a deep learning algorithm. Then an analysis report will be generated. Before sending this report to users, the analysis report will be sent to a remote hospital for verification by an expert, and then the report can be available to users on a smartphone. We have envisioned the hardware interface as having 3 major units: EEG and PPG acquisition unit, and a year-old mHealth device. Notable features will be disposable electrodes, easy to use, flexible positioning, portable, small, and lightweight. Electrodes and PPG sensors will have wired connection to the year-old mHealth device, and mHealth device will transmit data to a smartphone wirelessly via power-efficient Bluetooth. Look at the proposed hardware components. The primary idea of EEG acquisition unit will have 6 connected disposable electrodes, which will have flexible positioning, lightweight, and will be connected to the year-old mHealth device via wire. PPG acquisition unit will contain a reflectant mode PPG sensor, and the placement will be inside the ear canal. Year-old mHealth device will have an EEG biosensor module, microcontroller chip, noise reduction module, Bluetooth low energy system, and some disposable batteries. Based on our proposal, the mHealth app will include some must-have and convenient features such as registration, login, access to previous records, integration with mHealth devices, AI-assisted encephalopathy detection, encephalopathy risk assessment through mobile app, instructions to use, simple user interface, reminders, notifications, emergency help, symptoms tracker, in-app chats, user community, and a desktop software for analysis. I'd like to illustrate this point by showing you from menu bar, Home tab will allow to create new record. It will start from mother metadata fill-up form. This is the mother metadata which have to be selected if the relevant conditions are available, like obesity, cesarean delivery, etc. There will be instructions, calibration systems, and then EEG and PPG data recording will be started and live graph will be visible. After cloud server and processing, encephalopathy detection and severity scoring will be visible, and the verified medical report can be downloaded. Now, Nafisa will continue the presentation from here. Thank you, everyone.
Thank you, Tanzila. Now, I would like to emphasize on the benefits of our proposed solution. It not only detects neonatal encephalopathy accurately in a faster, more efficient, and reliable way, but also provides the severity grading score, which is essential for rapid intervention. Again, the 24/7 365 telemedicine services allows a remote physician to consult with an expert, diminishing the geographical barrier. Being non-invasive, it is a safe method of diagnosis. Multiple parameters being monitored by a single device efficiently reduces the cost of treatment or equipment involvement by many folds. Finally, this device, being an innovative concept, when launched, will hopefully become a potential source of income generation. We have envisioned the entire project pipeline in 2 years, starting from planning to concluding at a fully operational profit-generating state. We have segmented the project into several major modules, and an estimated amount of duration is allotted for each of them. After strategically planning and fundraising for 2 months, we will dig into data collection. Parallelly, the prototype development will be going on with the participation of dedicated hardware and software development teams. Data collection and prototype development are expected to be completed by the first year. This being done, an elaborate clinical trial and pilot study of around 5 to 6 months will be conducted, which will evaluate the feasibility, design competence, and adversaries of the prototype, and alterations will be made based on feedbacks in an iterative manner. Simultaneously, a preliminary licensing application will be submitted to DGDA. After the approval, the final prototype will be deployed and soft-launched after resolving the privacy and security issues. Next, after scripting and publishing of final reports, promotion by seminars and advertisements, market analysis, etc. will be done. Finally, the project will go into production, aiming for profit generation. Here, we can see a Gantt chart spanning 2 years. The previously discussed major work modules with approximate durations are graphically represented so that we can set targets and track the progress with ease. Let me now focus on the financial prospect of our project. We aim to raise initial funds in a way that will cover all the expenditures of the project from its initiation up to reaching the break-even point, where the generated revenue and the cost will be equal, and eventually the project will be turning to be a profitable one. We have defined 2 distinct financial phases on the basis of corresponding expenditure and turnover. During phase 1, because of the intrinsic nature of the works in R&D and clinical trial, there are only costs without any revenue, which highlights the need for an adequate budget for this phase. In phase 2, although we hope to start making little profits, yet a hefty amount of budget is required to keep going with the production, procurement, and promotion. Well, it is quite early to have a defined talk on our income generation strategies. However, I would like to give you a brief overview since we will be having the first mover advantage in this market. We aim to generate profits by individual sale of mHealth device or electrodes, premium app subscription fee, in-app advertising, collaborating with international franchise or value-added resellers, and last but not the least, the cost-effective package services comprising of a number of mHealth devices, defined number of electrodes, and 6 months of free premium subscription. As I mentioned while discussing the financial prospect, we have considered 2 specified phases for budget allocation. We propose a budget of 27 lakhs BDT for conducting phase 1, R&D plus pilot trial that covers all the associated HR materials and equipment costs. Next, for conducting phase 2, production, operation, and promotion, we estimated a budget of 31,55,000 BDT that include the cost of HR, procurement, operation, infrastructure, maintenance, marketing, and advertising. Thus, the total estimated budget of the project is 58,55,000 BDT or around $37,000 US. This brings me to the end of today's presentation. Thank you all. Please feel free to ask if there are any queries.